Hey pre-calculus, these are your 1.6 notes. This is probably 1.6a actually, I should say. We'll have other notes on this chapter, or this section. And they're modeling with equations is the title of these notes. Now, for the first example, we're actually going to look at example 2 in your textbook. So, let's see. Okay. Interest on an investment. And the first thing I do when I read a story problem is I just read through the problem once. So, Mary inherits $100,000 and invests it in 2 certificates of deposit. One certificate pays 6% and the other pays 4.5%, simple interest annually. If Mary's total interest is $5,025 per year, how much money is invested at each rate? So when I look at a problem like this, the first thing I do is read it, and then I'm going to just write down on my paper the important information. So coming back to the notes, you don't have to write out the entire paragraph when you're doing problems out of the textbook, just what's important. So there's a total of $100,000. That's one thing that's important. There's one certificate, I'm just going to put cert here, that pays 6% interest, and another at 4.5% interest. And the total interest is $5,025. And then after I write down what's important, I reread the question. This question says, how much money is invested at each rate? Your variable is always going to be basically the question written as a statement. So how much money is invested at each rate? X is the money invested at, oh shoot, I actually am going to need a Y because when it says each, that means there's 2 rates. So X is going to be my money invested at 6%, and Y is going to be my money invested at 4.5%. Now, this is called defining your variables. And to get full credit on a test or a quiz, you're going to have to do this step of telling me what your variables are equal to, defining what they mean. Now that I get these definitions down, I've defined my variables, I'm going to look back at the problem and start trying to come up with a model. Now, when I do this, I look for totals first, because those are usually pretty helpful. In this case, I have total money. So I've got the money in one account, plus the money in my other account, is giving me my total amount of money. So X plus Y equals 100,000. And then as far as interest goes, I have my interest at 6% plus the interest I'm earning at 4.5% is going to equal my total interest. So to write this out with variables, my interest at 6% is going to be 0.06, and let's see, I don't know how much I'm investing there, so X plus 0.045 Y, and that equals my total interest, which is $5,025. The reason I turned 6% into 0.06 is that 6% literally means 6 per 100. And on your calculator, if you were to do 6 divided by 100, you would get 0.06. And then the same thing with 4.5 divided by 100, you get 0.045. Okay. Now I've got 2 equations with 2 variables. And so there's a couple of different ways I could go. I could use substitution. So in this equation, I could get Y by itself. Y is 100,000 minus X. And then substitute it in for the Y in my second equation. If I did this purely algebraically, I would get 0.045 times 100,000 minus X equals 5,025. From here, I would distribute into my parentheses. So 0.045 times 100,000. Being careful to get all your zeros there is 4,500 minus 0.045x, and I have 0.06x over here, and this is still equal to 5,025. Then I can combine like terms. So 0.06 minus 0.045 is 0.015x. I can also take 4,500 away from both sides. So 5,025 minus 4,500 is 525. And then when I divide both sides by 0.015, I get x equals $35,000. Now, at the end of a problem, it's really, really tempting to just get a number and then stop. It's a good idea, though, to reread the problem. So if you go back, the question said how much money is invested at each rate. Well, the $35,000 is the money invested at, let's see, x was at 6%. So this is $35,000 at 6%. And so it's important that you go back and find y. Since y was 100,000 minus x, I can do 100,000 minus 35,000, which gives me, I think 65, but let's just double check. Yep, sure enough, 65,000. And that's at the 4.5 interest rate. And then because I've got so much work on the page, would you guys please make sure, especially on problem solving, to box your final answers, because sometimes it can be really hard on your homework or on a test or a quiz to see where the final answer is. So make sure to put boxes around them for me, please. Now, this isn't the only way that you could solve this problem, and so just to show you how you could do it, you could also do this one graphically. When in doubt, graph it out. So we had y equals 100,000 minus x, and we also had 0.06x plus 0.045y equals 5,025 at the beginning of this problem. If I wanted to graph this, I would need to get this equation, isolate y in the second equation. So I would say 0.045y equals 5,025 minus 0.06x. I would subtract this from both sides. And then I would divide both sides by 0.045. Now the beautiful thing about graphing on your graphing calculator is that you don't need to simplify anything. As soon as you get y by itself, even though this looks pretty ugly, frankly, I don't have to simplify it for the graphing calculator. The graphing calculator can take care of it for me. So in my calculator, I would go into my y equals, erase anything weird that's there, and I'm going to plug in 100,000, so 100, 2, 3, minus x, and I've got to put parentheses around this now because otherwise the calculator won't know what the top of the fraction is. So 5,025 minus 0.06x divided by 0.045. Now I'm going to need to adjust my window, and some of you guys are good at this already, some of you need some work. Usually using your table in your graphing calculator will help you adjust the window correctly. So if I hit second table, I can see that my y values are starting at 100,000, and that makes sense because I could invest 100,000 in one account and $0 in the other account, and they're going down from there. So when I'm looking at to make my window, since this x is really the money I'm investing, the smallest amount is 0, and the biggest amount is 100,000. So let's see, 100, yep, 1,000. And then I'm going to make my scale be exactly the same as the number above it, but just cut a 0 off. And then my y-min should be 0 because the y is the money I'm investing at the 4.5 rate, so that 0 is the smallest I would invest there. The most I could invest there would be 100,000. And I'll make the scale the same. I just make it the same exact number but cut off a 0. Now when I graph this, I get 2 lines. And I'm looking for where these 2 lines are equal, so I'm looking for this intersection point. So I hit second calc, intersect, enter, enter, enter. And sure enough, this happens at 35,000 and 65,000. If you decide to show your work graphically, you need to sketch me a picture of the graph. Now this doesn't need to be like any insane perfect sketch. It can just be a quick sketch of the graph and label the important part in the graph that gave you the answer. So in this case, it was that x was 35,000, y was 65,000, And then you would still need to write out your final answer, so this would be part of showing work. You would still need to write out your answer with units and 35,000 and tell me at 6%, like I did above, and box those answers for me, please. All right, that's it for video notes. Have a good night, and I will see you tomorrow.